Welcome back to Z Lessons. Here in this lesson, we are going to look at Theorem 9. Okay, I'm using this book that is also available. You can check in the video description below and you'll be able to see the link. And there, when you click that link, you'll be directed to download that PDF file. Okay. So in Theorem 9, we are talking about this special property about the tangent and the chord. So let me read the statement real quick, and we are going to get to the business of proving these theorems. It states that the angle between a tangent and a chord is equal to the angle subtended from the ends of the chord in the alternate segment. I know this is a lot to take in, but my friend, you are at the right place, and I'm going to do everything in my power to make sure that you understand this concept. Okay, so what this simply means is that when you have a tangent and a chord, they form an angle. As you can see, let me just zoom in here. As you can see here, we have this red line like so. So that's the chord because it touches one part of the circumference to the other part of the circumference of the circle. So as you can see, this is what we call the chord of this circle. And as you can see, this flat line, this horizontal line is called the tangent. Okay. If you don't know what the tangent and what the chord is, I have created videos in this playlist. Somewhere on top there, earlier I created these videos. You can feel free and check them out. So that's what's going on. So as you can see, when we have a chord and a tangent, they are forming an angle here, which is angle B. Okay, so now the statement said that the angle between a tangent and a chord is equal to the angle subtended from the ends of the chord in the alternate segment. As you can see, this chord here and this red chord, it has two lines, not so. This line goes straight to the circumference, then it goes back to the end of that same chord. As you can see, it forms an angle. So these ends, this end here and this end here, when we extend their lines like so, they are forming an angle here. So this is what they say subtended at the circumference. So this is the angle that they are talking about. So now, what do they mean that when they say in the alternate segment? So if you look at this diagram to your right here, as you can see, this gray area is what we call the alternate segment. So when we create a line like so, it touches the circumference, then back to the end of this chord. That means that the angle is created in this segment. So if that doesn't also make you understand this, I will show you what that means in a GeoGebra. So let us first read this other statement. The alternate segment to an angle between a tangent and a chord is the segment on the other side of the chord. So as you can see, this is the chord right here, this red line. So the other side of this chord is this side. We have two sides to this chord. We have this side here, then we have this other side on top like so. So this means that this is the other side they're talking about. Not this side where the angle is being formed, but this other side. So let us go back to GeoGebra and I'll show you what they mean. So this is GeoGebra. So let me create what has been talked about in that theorem. So this will represent our circle like so. Okay, so that's our circle. Let me just delete that. Let us add the tangent. So I want our tangent to be somewhere here. So I'm going to go select the tangent tool like so. So there you have it. That's our tangent. So let me add our chord. So this is just a line like so. As you can see, we have the two requirements for this theorem. let me just color this code so that you can see properly. So the red thing there is our code. Let me see if I can like increase the length. Let's just make it 8, the thickness. So that's our code right there. Then this other let me just add it in a blue. So that blue line there is our tangent. So this is what the theorem meant. It meant that whenever we have a chord, this is the chord I've represented in a red line, and a tangent, this blue line here, it forms an angle. As you can see, this angle is equal to 55.9 degrees. It's stated that it's equal to the angle formed in the alternate segment. So let me create that alternate segment for you. Let me first click the center point like so, then let me do like so that you can see the alternate segment. As you can see, that's the segment we're talking about right there. So yes, that's the alternate segment. Okay, we have two segments. Let me create another segment so that you can see what I'm talking about. As you can see, we have two segments. The one that is in this sort of red color, and the one that is in a green color. So as you can see, this angle is formed in this segment that is in a green color. But the theorem says that the angle between a tangent and a chord is equal to the angle subtended from the ends of the chord in the alternate segments. I want you to notice this statement. Angle subtended from the ends of the chord in the alternate segment. By subtended, this is what they mean. As you can see, this end of the chord goes to the circumference, then back to that other side of the chord. So that's what they mean when they say subtended. So as you can see, this chord right here, this red line, is forming an angle there at F. So that's what it means. So this angle here is equal to that angle subtended by the chord in the alternate segment. So as you can see, the alternate segment to this angle that is here is this segment that is in a red color or in a red fill. So as you can see, this angle that we have been given, or this angle that we have measured, is in the green segment, not so. This segment at this side of the chord. So the alternate segment to this green segment is this segment in a red color. So that's what it means. So when we measure, you will see what will happen. Let us measure angle DFC. And as you can see, it's exactly this angle. So this is what they mean. This angle formed by the chord and the tangent is equal to the angle created in the alternate segment. So in this segment, this is the first segment. Now they are talking about this one in the red color, as you can see. So no matter how many times I move it, as you can see, it's always going to be equal the angle in the alternate segment, as you can see. So I've created another angle like so, just to demonstrate what I'm talking about. So if you see, this angle here is formed by this chord and the tangent, not so. So as you can see, this chord has two ends. It has an end point here. It also has an end point here at F. And as you can see, it forms an angle here. So therefore, this is the alternate segment of this angle. So this angle is equal to this angle in there. Let me measure it and you will see what I'm talking about. As you can see, that's the angle. So as you can see, this is what the theorem states. So this angle is the equal to the angle in the alternate segment, which is the angle here. Okay, so let me recap real quick of what I've just taught. When we have a chord and a tangent, they form an angle right here. As you can see, this is the angle formed there. So this angle will be equal to the angle created by this chord in the other segment. By the way, this chord here can form two angles. Let me show you what it means. As you can see, it can form, as you can see. So as you can see, this is what they mean. As you can see, this red line here and this blue tangent here, they form an angle, this angle here. So this angle is equal to the angle formed by this chord in the alternate segment. So the alternate segment of this angle is this red segment, not this green segment, this red segment here. As you can see, this chord is forming an angle at F. It is also forming an angle at H, but we are told by the theorem that that angle should be in the alternate segment. So the alternate segment to this angle is the angle that will be formed in the other segment. As you can see, not this segment in here, but that segment in the not this angle here, but this angle in this red segment here. So this also applies to this angle right here. So this angle is going to be equal to the angle formed by this chord in the other segment, which is D, here at D. So that's what the theorem means, as you can see. So let me show you a scenario of how a question might come in the exam. So as you can see, we may have, let's say, let me just do this. We might have a question like this, then it comes in the exam and you are asked to find an angle here. Let me show you a question, by the way. If you look at the exam that came in 2020, is it 2024? I think it's 2024, last year. As you can see, this was what is happening. So as you can see, this is the question that came. This is very important. We have a radius, we have a tangent, and we were asked to find angles. And as you can see, this is the answer on question 2. Alternate segment, as you can see. So this is what's happening. So these questions, my friend, come in the exam. Okay, it's very important that you understand them. So this can be a scenario of how a question might come in the exam. As you can see, we have the radius, the tangents, and all that stuff. Then you are required to find this angle F. So how are you able to find angle DFC? So now, as you can see, DFC is in the alternate segment to what? To this angle here. So therefore, this angle is equal to that angle. Let us measure it, and you will see that that's the answer. And as you can see, that is the answer, because this angle is equal to the angle formed by this chord in the alternate segment, which is this segment in the red color. So that's what it means. Okay, this marks the end of these theorems that we have been discussing. In the next video, we are going to answer and solve the examination questions that have been prepared by the Examination Council of Zambia, and we are going to apply all these theorems and all these concepts that we have learned, and we are going to use them to solve these examination questions. So join me in the next videos, and make sure to subscribe so that you get notified whenever we post a video of that nature. Like the video if you liked it, share it with your family, with your children, and all that stuff, and I'll see you in the next video. Have a nice day.